I'm here to talk to you today about how web pages work. The first step is you type a URL into your browser. This can be Facebook, Google, wherever you want to go. Your browser then looks up the IP address for the domain name that you typed in. Well, what is an IP address? Computers do not use domain names to reference where the server is located on the internet. It uses something called an IP address, which is much like an address to your house, but it is a set of 4 3-digit numbers separated by periods. This IP address references the location to which the server is stored. It looks up the IP by going to your ISP or Internet Service Provider and searching for the permanent IP that is registered to the domain that you typed in. It will start with a top-level domain such as .org, .com, .edu, and a few others. These split up the domains into different groups and make it easier to search through all of them. This is brought to you by TCP IP Illustrated by Richard Stevens, which is a well-known networking book. And here's an example of the browser performing a DNS or domain name server search. Let's take a look at going to netflix.com. After we do our DNS lookup and find Netflix at an IP address of 54.172.208.117, we're ready to talk directly to Netflix's servers.
Now that we have an address of the computer we want to talk to, we now need to figure out a way to get there. You probably know that you connect your phone or laptop or another device to a router. A router, as you might have guessed, is responsible for routing internet traffic. A router connects two devices together and forwards packets based on a final destination. Your device will send a message to the router with a note saying, "Send me to 54.172.208.117. This message is called a packet. The routing process is pretty straightforward and fast. If it knows how to talk to a certain IP address, send that message to that computer. If it doesn't know, forward it to another router which might know. That router will follow the exact same logic. Your packet will go through many routers before reaching its final destination. Once Netflix gets your message, they'll send you a message back through the exact same process. These rules let the internet have an interesting feature. If a connection between two routers goes down or has lots of traffic, a router can elect to divert traffic to a different router. You can think of routing internet traffic through the internet as the postal service. You write a letter to tell the postman to deliver it to 100 Winchester Circle, Los Gatos, California, where Netflix has headquarters. The postman will take it to your local post office before going on to California via an airplane or truck, onto a regional distribution center for Santa Clara County, to Los Gatos' post office, to 100 Winchester's postman, and finally to 100 Winchester at Netflix. In fact, we can see the route a message to the internet takes. Packets or messages on the internet start at your device, get sent to your Wi-Fi router, which sends it to another router, which sends it to another router, and so on until the packet reaches its destination based on simple rules.
After getting the permanent IP address for the domain, the web browser then sends an HTTP request called GET to the web server located at the permanent IP. The request contains the name of the URL and what it is expecting to receive back. The web server then validates the request and sends back instructions for your web browser on how to display the web page. Your browser will begin to start following those instructions. While following the instructions, there might be other instructions to fetch objects that are embedded in the web page, like images, style sheets, and scripting files. These files tell your browser how to display objects in the web page and make things move on the page. Your web browser then sends continuous requests until it is able to display everything. This ends the life cycle of the web page.
So we've discussed that packets are just units of data and how they relate to internet traffic. Now we need to understand what happens when they travel throughout the network. Ever wonder why the internet in your household slows down when someone is streaming YouTube? This is because video files are quite large, so in order to stream video, multiple packets are being sent to your internet, which in turn uses up your bandwidth. To do this, the internet has two different types of protocols: Transmission Control Protocol, TCP, and User Datagram Protocol, UDP. The two main things you need to know about these connections are that TCP is reliable but slower, whereas UDP is fast but not as reliable. Aside from just media streaming, these protocols are used for all internet traffic. According to Douglas Comer's Internet Working with TCP IP book, the whole design of a TCP connection is to ensure complete reliability. Examples of this would be when visiting web pages or streaming video from a server like Netflix. The way TCP works is by sending a stream of packets to deliver its data. Each packet is numbered so that the recipient knows the exact order. Once received, the recipient sends a response back to the sender to let it know to send the next stream of packets. There is also a timeout so that the sender knows if it should send the stream of packets again, if it doesn't receive a response. This is what happens when you see Netflix video buffering. Now you might ask, why use UDP at all? Well, it's true that TCP is very reliable and nowadays prioritized, But the way UDP works is by sending packets endlessly without waiting for a response. This is good because it ensures that there is continuous information being sent back and forth, whether some of it is received or not. An example would be like video games that require fast information from server to user. Activision argues that in a video game like Call of Duty, the game doesn't have time to get hung up on some missed data when so many players are playing across an online platform. Instead, the video game prioritizes receiving the next incoming packet so that it can continue the game at a fast pace. So in conclusion, the internet communicates in two different methods: TCP to ensure reliability, or UDP for speed and efficiency.